Hello, everyone. This is my Lab 3 physics project presentation on black holes. So for the introduction, the overview of this lab was to identify an initial velocity for the spaceship that is involved, where the trajectory does not crash into the black hole or the planet. The methods in this case were, of course, using VPython through simulations. For the result, the mass of the black hole and as well as the initial velocity was found. And for a brief description of the principles, Newton's second law, the universal law of gravitation as well as the momentum principles were utilized. On a deeper dive, in addition to all of those, the velocity and position update formulas were also used. And we could see the formulas actually on the screen for universal gravitation, as well in this case as momentum, where net force is equal to the rate of change of momentum over time. For the first part of the lab, we have some initial assumptions where the net force is equal to the force of gravity for the respective objects because we are in space and nothing else has a force except for gravity. And since gravity is non-constant, the average velocity can be replaced with final velocity. For part one of the lab, the system is just the star and the black hole. Diving into the code, we see some initial conditions where the only change was the time interval, since we are looking at per day instead of per second. And for the actual changes within the while loop, the initial and final momentums were first identified, and then the changes were found with the final velocities minus the final initial velocity, as well as p final minus p initial. Then the rate of change of momentum was found through the change in momentum over change in time, which is equal to the net force in this case. To find the parallel rate of change in momentum to p hat, we had to find the magnitude of the rate of change of momentum, and then to multiply it by the unit vector p hat to identify the parallel momentum change. Then to find the perpendicular momentum change, I just used the net rate of change of momentum minus the parallel portion to find the resultant, which would be the parallel. Finally, to look at the force or the mass of the black hole, not the force, I rearranged the universal gravitation formula and isolated the mass of the black hole, which you could see at the very end of the second picture. For the results, I found the mass of my black hole to be 1.6 e to the 34, with a net force of 9.89 e to the 28, as well as the perpendicular and parallel components of the net force. For the second part of the lab, the system now includes the star, the black hole, as well as the rocket ship, and the initial conditions are pretty similar with the included mass of the black hole that we found in part one, as well as a planet and ship mass and the universal constant of gravity. To find the net forces for both the planet and the ship, the component forces needed to be identified, which was the force of the black hole on the planet, the force of the ship on the planet, the force of the black hole on the ship, and the force of the black hole, the force of the planet on the ship. After these were identified, it was just as simple as adding the components of the forces to find the net force on each object. To make our simulation actually move, we needed to use the velocity and position update formula. And through guess and check, I found an initial velocity where the rocket ship would not crash into either the black hole or the planet. So for some errors, in part one, the accuracy in the mass of the black hole definitely could be improved if the averages were more specific or more consistent. And for part two, since it was a guess and check determination of initial velocity, there could, of course, be a closer trajectory in which the spaceship flew past the black hole. For the net force and its parallel and perpendicular components being different from the rate of change in momentum, this can be true, or this is true, in cases where the net force involves many different instances of forces. Since, though, in our lab or in our presentation, the only net force in the first part of the lab is the force of the black hole acting on the star, the rate of change in momentum is equal to the net force. In the second part of the lab, though, we see that we have to add all of the components of the rate of changes of momentum to actually find the net force components. And for the what if with the initial velocity, I found a initial velocity of negative 2e to the 6 in the x component and 10e to the 6 in the y component, where the spaceship would actually orbit around the black hole. Thank you very much.